So, without wasting the time, now we try to find out a Laplace transform of some elementary function. So, what is the first elementary function? So, here first we write a Laplace transform of a elementary function. Laplace transform of elementary function. Laplace transform of elementary function. So, first function is a first elementary function is a ft equal 1. So, what is the Laplace transform of a 1? So, by definition of, now how we find the Laplace transform of this function? Laplace transform of this function can be find with the help of a what? With the help of a definition of a Laplace transform. As we know that, what is the definition of a Laplace transform? Laplace transform of ft equal 0 to infinite e to power minus st ft dt. So, here ft is a what? Ft is a 1. So, here we put the ft equal 1. So, here we write L with a 1 equal 0 to infinite e to power minus st, and in place of ft we write what? In place of ft we write a 1 dt. So, if we find the integration of a e to power minus st, as we know that integration of a e to power minus st is a e to power minus st divided by minus s, lower limit with a 0, upper limit with a infinite. So, s is not a variable. So, this will come outside, this will come minus 1 upon s, inside e to power minus st. So, if we put the limit, this become e to power minus infinite minus e to power 0, and as we know that what is the value of a e to power minus infinite? E to power minus infinite with a 0. So, this become minus 1 upon s, this becomes 0 minus 1. So, minus become plus. So, what is the Laplace transform of a 1? Laplace transform of a 1 become what? 1 upon s. So, this one is a first elementary function, Laplace transform of a first elementary function. Now, what is the second elementary function? Suppose ft equal what? Second elementary function, let ft equal t. So, now again by the definition of a Laplace transform, definition of Laplace transform what will happen? As we know that what is the definition of a Laplace transform? L of ft, Laplace transform of ft equal 0 to infinite. So, one thing here there is a need to clear, here s must be greater than 0. Otherwise what will happen? This become minus 1 upon s. So, here there is a need to mention what? S is greater than 0. So, Laplace transform of ft equals 0 to infinite e to power minus st ft dt. So, what is the ft here? Ft is a t. So, here just we write in place of ft write a t, then 0 to infinite e to power minus st, in place of ft we write a t dt. if we find the integration of e to power minus st t, then this become what? T into e to power minus st, e to power minus st upon minus s, lower and upper limit become 0 to infinite. Second function become what? Minus minus plus, integrate 0 to infinite, derivative of a t is a 1, e to power minus st upon minus s, minus minus become plus, so this become 1 upon s dt. So, if we put the upper and lower limit, the value of a first term become 0. The first term become 0. And if we integrate the second term, then this become again e to power minus st upon minus s. So, this become 1 upon s. Here we write what? Integration of e to power minus st upon minus s. Limit is a 0 to infinite. And again what will happen? This become what? This become, if we put the upper limit, minus 1 upon s outside, so this become minus 1 upon s square. If we put the upper limit, this becomes 0, and lower limit, this become minus 1. So, this become 1 upon s square, provided s is a greater than 0. So, what is the Laplace transform of ft? So, here we write, if we write here Laplace transform of a t, Laplace transform of a t is a what? 1 upon s square. Laplace transform of a t is a 1 upon s square. So, in a similar manner, if we find the Laplace transform of a t square, as we find the Laplace transform of a t is a what? 1 upon s square. In a similar manner, if we find the Laplace transform of a t square, in place of a t we write what? In place of a t we write a t square, and simplify the find the value of integration and putting the upper and lower limit, then we find what? Then we find 2 upon s cube. 2 upon s cube. Similarly, if we find the Laplace transform of a t cube in a similar manner, then we find a 6 upon s to power 4. So, in a similar manner, if we try to write, this can be written as a factorial 2 upon s cube, and this can be written as a factorial 3 upon s to power 4. S to power 4, and in a similar manner, Laplace transform of a t to power n equal what? Factorial n, because if there is a 3, then factorial 3. Factorial n upon s to power n plus 1. S to power n plus 1. And this can be also written as, in some books, this can be also written as in term of a gamma. Gamma n plus 1 upon s to power n plus 1. Gamma n plus 1 upon s to power n plus 1. So, this one is a what? Because we know that what is the gamma n plus 1? Gamma n plus 1 equal what? Gamma n plus 1 equal n gamma n. N gamma n, and in similar manner, if we find the value of a gamma n plus 1s, this one is a factorial n. N gamma n, then again gamma n can be written as a n minus 1 plus 1. So, this become n into n minus 1 gamma n minus 1. Similarly, n minus 1, n minus 2, n minus 3 up to 1. So, this one give the factorial n. So, this one is a what? This one is a property of a gamma function. With the help of a property of a gamma function, be able to write Laplace transform of a t to power n equal factorial n upon s to power n plus 1 are equal to the gamma n plus 1 upon s to power n plus 1. We also are directly able to find the Laplace transform of a t to power n using the definition of a gamma function. How we find? Suppose here we try to find out the Laplace transform of a t to power n using the property of a gamma function. So here third one is a what? Ft equal t to power n. We may able to find out the value of a Laplace transform of t to power n in this way. Also using the definition of a Laplace transform, we also able to find out the value of a Laplace transform of a t to power n. How we find? Just by the definition, write a definition of a Laplace transform. Here we write by the definition of a Laplace transform. By the definition of Laplace transform, definition of Laplace transform, Laplace transform, Laplace transform. What will happen? Laplace transform of a ft equal 0 to infinite e to power minus st ft dt. Now ft is a what? Ft is a t to power n. So here we write in place of a ft we write a t to power n, Laplace transform of a t to power n. In order to find out the Laplace transform of a t to power n using the gamma function. So we use the one property of a gamma function. What is the property? Property of a gamma function is a 0 to infinite e to power minus ax x to power n minus 1 equal x minus 1 dx equal gamma n upon a to power n. A to power n. So this one is a what? This one is a property of a gamma function. So we are going to use this property here. So first of all we try to write this integral means 0 to infinite e to power minus st in place of ft what? T to power n dt. So first of all we try to write this integral in this form. So how we write? Here 0 to infinite e to power minus st t to power n can be written as n plus 1 minus 1 dt. So if we closely observe here and compare this integral by this integral, then s is replaced by what? A, and n plus 1 can be replaced by the n. So what is the right hand side? So right hand side in term of a gamma function become gamma n plus 1 upon s to power n plus 1, s to power n plus 1. So this become what? Gamma n plus 1 is a factorial n upon s to power n plus 1. So either we derive using the gamma function or we may also derive successive derivation approach. Okay. So you may derive either using the property of gamma function or using the property using the successive derivation, derivative by induction. So finally what will happen? Laplace transform of t to power n become what? Laplace transform of t to power n become gamma n plus 1 upon s to power n plus 1, or we may write this one factorial n upon s to power n plus 1. So whatever the power of a t to power n, then be able to directly write the Laplace transform of any power of a t. For example, if we try to find out a Laplace transform of a t to power 3. So what is the value of a n? N is a 3. So here we write a factorial 3 upon s to power 3 plus 1. So this become what? 3 into 2 divided by s to power 4. This becomes 6 by s to power 4. So this one is a Laplace transform of a t to power 3. Now next elementary function is a what? Next elementary function is a e to power at. Now how we find the Laplace transform of e to power at? Third elementary function is a third elementary, or we may say fourth elementary function. Fourth elementary function is a what? Ft equal e to power at. E to power at. So how we find the Laplace transform of a e to power at? E to power at, very simple, using the definition of a what? Using the definition of a Laplace transform. By definition of Laplace transform, by definition of Laplace transform, what will happen? Laplace transform of a ft equals 0 to infinite e to power minus st ft dt. So in place of ft we write what? In place of ft we write e to power at. So Laplace transform of a e to power at equal 0 to infinite e to power minus st into e to power at dt. So if we simplify, this become what? This become 0 to infinite e to power a minus s t dt. So what is the value of integration? The value for this integral equal what? 1 upon e to power a minus s t upon a minus s, 0 to infinite. 0 to infinite. So if we put the lower and upper limit, a minus s is free from t, so this become outside, a minus s inside e to power a minus s e to power a minus s t 0 to infinite. So if we put the upper and lower limit, a minus s, upper limit e to power a minus s t, so this become e to power 1 upon e to power minus infinite. So what will happen here? E to power infinite. So we may write here, this one is a, this one becomes 0 minus 1. So what is the value? Value become 1 upon s minus a. 1 upon s minus a. So this one is a Laplace transform of a e to power at. You may also write here minus of s minus a. So this become e to power minus of s minus a, e to power minus infinite, e to power minus infinite become 1 upon e to power infinite, 1 upon infinite become 0. So 0 minus 1, because e to power 0 become 1. So 0 minus 1. So Laplace transform of a what? Laplace transform of a e to power at is a what? 1 upon s minus a. So here we write what? Here we write Laplace transform of a e to power at equal 1 upon s minus a, s minus a, s minus a. So directly we try to find out Laplace transform of a e to power 2t. So what is the Laplace transform of a e to power 2t? 1 upon s minus 2. So we may use this result as a formula. So all the elementary function, Laplace transform of all the elementary function treated as a formula. So in order to find out the Laplace transform of e to power 3t, this become 1 upon s minus 3. So this one is the Laplace transform of e to power at.